Okay, this video is over the 2015 AP question number 2, just the gas law kind of question. So I'm doing A and B. So anyway, 2A, number 1 says, calculate the number of moles of C2H4 that are actually produced in the experiment and that are measured in the gas collection tube. Okay, so there's kind of a key word, this actually right here, that produced and measured in the gas collection tube. Okay, so they're want to figure out the moles, but what's affecting this experiment, or to figure out the moles, is the conditions at which the gas is collected. So that's a big clue that you're going to have to use this equation for doing it. You're going to have to use the PV equals nRT. So that's what we're going to do for number 1 here. Okay, so first of all, we have to know what the pressure is. And so the pressure that is given ends up being, it says that the gas was collected at 0.822 atmospheres. So in the tube right here, the pressure is 0.822 atmospheres. But there is a problem. Whenever you collect a gas over water, you have to account for the vapor pressure of water that is also in the test tube. So you end up having to subtract it. So the thing is, they're telling you that the vapor pressure of water is 35.7 torrs. Well, the thing is that the vapor pressure of water is in torrs, and the pressure in the tube is in atmospheres. So what you got to do is you got to change this torrs to atmospheres first. So you would take 35.7 torrs, and then you could look up on your AP formula sheet that 1 atmosphere is equal to 760 torrs. And if you do the math, what you end up getting is this amount is 0.0470 atmospheres. Okay, that's the vapor pressure of water in atmospheres. Okay, up here is the pressure total. That's what that equals. You have to subtract the pressure from the water vapor pressure, and that's 0.0470 atmospheres. And what that's going to tell you is the pressure of the ethene that you collected, and that's what you want. So we can plug that pressure into P right here. And so if you do the math there, you get that equals 0.775 atmospheres. Okay, so now we have our pressure. All right, we know the volume, it's giving us that as 0.00854, so we know P, we know V. We're going to be solving for N. The R we can look up on the AP formula sheet, and the temperature is 305 Kelvin. Okay, so I think we're ready to plug everything in. So we got PV equals nRT. We're going to be solving for N, so we're going to divide both sides by RT. And basically when you do that, you're going to get N is equal to PV over RT. Okay, let's plug in the numbers. So the number of moles is equal to P. Okay, so we're going to use our corrected pressure, 0.775 atmospheres, times V, and the V is given to be 0.0854 liters. We're going to divide that by R, which is 0.082 06 atmospheres times liters divided by moles Kelvin. That's just the unit. Okay, and times T, which is 305 Kelvin. And if you do all that math, you would get that N is going to be equal to 0.002, let's see, we got 3 significant 264 moles. All right, so that's how to do this I right here. So to actually produce, you have to use the gas law data. Remember that you always have to account for the vapor pressure of water. They will give it to you in the problem, and you have to make sure that you take away the vapor pressure of water so you just get the pressure of the gas. Okay, let's do this one right here. Okay, that would be produced if the dehydration reaction went to completion. So anyway, this one is saying if all of the ethanol would react, okay, how many moles of this ethene would you get? And so it's giving you in the problem that you have 0.2 grams, so we have 0.200 grams C2H5OH. All right, now we can do a stoichiometry problem to figure out how many moles we would get. So we're in grams, we've got to change to moles. So 1 mole C2H5OH, and let's see, they're giving us that as 46.1 is the molar mass. They give that to you in the problem. That's nice, you don't have to add it up. Alright, then we're going to do the mole ratio from the balanced equation. So for every 1 mole of this C2H5OH, you're going to get 1 mole of C2H4. And if you do that math, that's going to tell you how much CO4 you should get if everything worked out perfectly. 0.00434 moles. I went to 3 significant digits because this has 3 here, so I went to 3 here. Alright? Okay, so that's how much would be produced. Okay, calculate the percent yield. Alright, let's just go to a different page to do that. So, to calculate a percent yield, you got to know that percent yield is equal to the actual yield, like how much you would actually get, divided by the theoretical yield times 100. So, we have to go back to the first problem. That's going to be the actual yield. So, 0.00264 is what we got. So, that's going to be 0.00264 moles divided by what we should have gotten, that's 0.00434. So divided by 0.00434 moles, and then we'll multiply that times 100, and that will give us our thing. So if you do the math, we got 1, 2, 3 significant digits. So your calculator should round it to 3. Oops, don't want that. So I need my pen. Okay, so it's 60.8%. Okay, that's the percent yield. All right, that's it on this problem.